Okay, so welcome to the next garage, and today I'm just going to be teaching you guys how to do some basic structural analysis. So let's say you're a welder or pipe fitter in the trades, and you have a project going on, like you want to build a workbench or a trailer, and you want to see how many pounds is it rated for, right? Will this W6 steel beam handle 5,000 pounds, or will 10-inch by 10-inch angle iron, how many pounds is this rated for? So this is what I'm going to do. So let's say we have a project, right? You're going to want to memorize. So basically, why is this important, right? So here's a project I did. It was basically a motorized bike, and we have 5/8" axle stock, and that actually sheared off, and it sheared off because it was too thin, right? So how would I know that it was too thin? Well, you don't know unless you modeled it in structural analysis. So that's the thing. And a lot of times structural analysis is kind of complicated, a lot of high-level engineering terms, but today we're going to clarify all that up. All right, so this is why it's important. You don't want an axle breaking on you at 30 miles an hour, or your trailer just snapping in half or something like that. So this is why it's important to learn structural analysis, and today I'll be teaching you that. So to learn structural analysis, this is for the lay people out there. You're going to want to know these two websites, calcusource.com, and they have a moment of inertia calculator. They have all moment inertia tools. They got, rectangle, solids, tube, stock, I-beam, H-beam, angle iron, etc. Circular area for axle, stocks, tube, channel T, all that. And then you're also going to want to do SkySieve. SkySieve is a free program. You're just going to type in skysieve.com. You're going to have to log in, sign up for free, and it's a fantastic free program. So once you sign up for all that, you're going to basically pop up the screen, and you're going to click on beam. You're going to launch a beam. You could also create your own custom sections over here, but that's just nonsense. Don't even bother doing that. That's So let's say we have a project. So you're going to want to first change the units to imperial. That's pounds, inches, or feet. Imperial KSI, 1,000 PSI. So let's say we have a 48-inch beam for a workbench, and this is a welding workbench, and we're going to be putting engines and very industrial stuff. So we want it to support 1,000 pounds. So we're going to obviously, so let's say we want 1,000 pounds distributed load on this workbench, right? So obviously 1,000 pounds. Actually, let's do a point load. So a point load is basically a load at a certain point. So let's say we add a point load halfway in the workbench would be 24 inches, right? And we add 1,000 pounds, right? So we're gonna, come on. Okay, so there we go. Now, obviously, this is our beam. We're gonna have to add supports on each end, right? Because a beam is not just floating in air. So you would just do that. Okay, so let's say we want to make it out of angle iron. Let's say this is for a trailer, and the main beam is 1,000 pounds or whatever. So you would put in your parameters here in calc resource. So basically we have a LX value of 0.66. Actually, let's first try 2-inch channel, right? And a 1/4-inch thickness. So IX is 0.34. So that basically is the moment of inertia. The moment of inertia is useful for comparing how strong beam sections are. You could look at different shapes like angle iron, steel beam, and just compare their moment of inertia, and it'll tell you which one's stronger than the other. It's like looking at, I guess it's a good way of comparing things. So you're not going to use the LY and the LXY. That's extraneous. Don't even use it. LY is useful if you're rotating your steel beam 90 degrees to the Y-axis, how strong it is. Obviously, when you have an angle iron or steel beam, you're not flipping it upside down or sideways, so that's not even useful for, normal people. So then what you're going to do is you've typed in your parameters, 1,000 pound center load. You could also add a distributed load if you wanted to, but we're not going to do that because, that's not really necessary. So what we're going to do is we're going to add edit section. So obviously we're using steel, so you would just select this parameter, and then our moment of inertia for 2-inch angle iron, a 1/4 inch thick, is 0.35. So you would just type in 0.35. So then what you do is, once you're happy with this setup, 48-inch beam, 1,000 center load, 1,000 pounds, you got that. You would click on solve, and this is all free, all this stuff, and then it tells you, this basically tells you a shear force diagram, which basically tells you it's really not really that necessary. This part is in compression, and the bottom part is in tension, so that's why this one's positive and this number is negative, but that's really not necessary. You have bending moments. Basically, obviously, the closer you are to the center of the beam, the higher the force. This is in foot-pounds of force. So this is all just extraneous. Unless you're engineering, you don't really care about that. So this is what's really important, deflection. Deflection is important because in all building codes, they have the standard deflection with obviously L/360. Like if you just Google standard deflection, L/360. What does L/360 and 240 mean? So this is standard, right? So this is it has to meet L/360, and it's in red because it failed. So obviously we know this does not be safe to run on the road because the beam would deflect too much and it would not meet the spec. So then that tells us we need a thicker beam, or we have to put less weight because this beam, it will fail. It's not rated for that by the standards. So then you would say, okay, maybe let's try 3-inch angle, right? 3-inch angle, right? Okay, the LX is 0.24, the IX, moment of inertia. So then you would go back, you would edit your section like that. Submit it, and then you would solve the beam. And look, it passes. The deflection is now 6/100th of an inch. So it tells you put 1,000 pound center load, the deflection would be 6/100th of an inch. So that looks pretty good. So I'm happy with that. So that's why you would use this. And now we're going to talk about distributed load. So basically the way distributed load works is, let's add a distributed load. So let's say this is a whole workbench and it's 1,000 pounds of crap on it, right? So 1,000 pounds distributed over 40 inches. So you take your 1,000, divide it by 48, and that's around 20, because 20 times 48 is 960. So your start and end. So basically, that's your distributed load. 20 inch pounds, which is actually 240 foot-pounds because you multiply that by 12. So that's a distributed load, 1,000 pounds distributed load, 20 times 48 is 960. Close enough. You solve, and you see if it'll take 1,000 pounds distributed load, and it's perfect. The deflection is only 3/100th of an inch, which is around a 32nd of an inch. So passes, perfect. So these are what you're going to want to do. So this is what you're going to use this software. You're going to use SkySieve for your modeling, and to get your structural data, you're just going to use this moment of inertia calculator. Okay, and has all the tools you need, and that's about it for this video. Yeah, so that's that. And just smash that like button to support the channel and the algorithm, YouTube algorithm. So thank you for your time.